Okay, so we're doing sequences and series. So the first thing I want to tell you is the difference between a sequence and a series. So a sequence is just a list of numbers, okay? And hopefully, if we're studying it, there's a pattern to the list of numbers. Okay, I see Lauren squinting back there. Maybe that? Better? Zoom out a little bit. How about that? Okay. So a list of numbers, just an order list of numbers, okay? So we've got 1, 1/2, 1/4, 1/8, okay? That's a sequence. If you decide you want to add up those numbers, that's called a series, okay? And so sometimes we want to predict what the next term in a sequence is going to be. Like maybe you have that pattern going. I mean, do you see a pattern in that first set of numbers? What's happening? Yeah. Divide by 2, taking half of it each time. You're all right. Okay, so we could definitely like figure out what the 10th term is. Okay. Also, sometimes we want to know the sum of those terms. Okay, and so when you're finding the sum, we call it a series, and that's another thing we're going to do. Some sums we can find even if they're infinite. Okay, so a couple of things. I'm jumping ahead of myself, but the formal definition of a sequence is a discrete function. Now, the word discrete just means they're separate values. Whose domain is a set of positive integers. Z plus means positive integers. So Z means integers. The plus means positive integers. But discrete means they're separate. They're not continuous. So you're 1 and then 1/2 and then 1/4 and then 1/8. You're not all the numbers in between. Okay, so continuous would be if you were all the numbers between 1 and 1/2 as you were going down. But discrete means you're just each one of those separate values. And so you can have two kinds of sequences, finite and infinite. Finite is if it ends, infinite is if it does not end. The same thing with your series. Okay, they can be finite or infinite. And sometimes we want to find the sum. We can find the sum of some infinite series. Some of them we can't. The one you see right there, we can. Okay, and you did it in Algebra 2, actually. The sum of an infinite geometric sequence. Do you remember doing it? Sort of, a little bit. Okay, and that's the only kind you'll have to find now. If you actually take Calc 2, y'all are going to do some calculus next year, but not all the way to what would be Calc 2 in college. You can actually sum infinite series besides the geometric ones, but certainly not all of them. Because if you think about it, for one thing, the series would have to be decreasing. That's just kind of a given. But if you had a sequence and the pattern to it was that you were multiplying by 2 every time, okay, and then you said, well, what would happen if I added these? Okay, so if I made it a series, okay, so when we were talking about this series, adding them all up, well, what's happening is you keep adding a larger and larger number. So if you keep adding a larger and larger number, it's just going off to infinity. Okay, that's just going to be a huge sum. Basically, to have any shot at doing a sum, you have to have a decreasing sequence, and then it's a decreasing series when you add them all up. But we'll talk a little bit more about that. But again, you can take a whole course in deciding which of these are converging, meaning they're going to a certain number, or diverging, going to infinity or negative infinity. But we will just be doing the geometric. Okay. There's two kinds of formulas that you can use to talk about a sequence. There is what's called an explicit formula, and the other one is called a recursive formula. The explicit formula is when you can substitute in, if you want to know the 10th term of a sequence, you can just plug in 10 to a formula and it'll tell you the 10th term. Okay, that's explicit, meaning you can go right to the term that you want. And I'm going to demonstrate one of each of these. So a recursive formula depends on the terms before it. So it might say to get the 3rd term, you add up the 2 previous terms. And then to get like the 4th term, you'd have to add up the 2nd and the 3rd term. Which is not very difficult unless you want like the 100th term, because then you have to do all the terms before it to get to it. So it's really kind of annoying. Whereas explicit, you could just substitute in 100 and go straight to the 100th term. Okay, and so the first kind that I have for this is going to be the explicit kind. Okay, and it's giving me a formula for u sub n, which is going to be the nth term of a sequence. Okay, so this refers to the nth term. Okay, and so to figure out some terms in the sequence, you start with 1. That's why we said positive integers. Okay, so the first positive integer is 1. You substitute in 1, then 2, then 3 to find all your terms. Okay, so if I substitute in u sub 1 would mean the first term. So you'd put in 1 minus 1 over 1. And what would you get? Okay, and then u sub 2, you just put in 2. So 1 minus a half. And we'll do one more, u sub 3, 1 minus 1 over 3. Okay, and so I'm just going to write those out. 0, 1/2, 2/3, and we could keep going. And if I wanted the 100th, it would be 1 minus 1 over 100. So it would just be 99 over 100. Okay, so I could get to any term I want really quickly. Now this negative 1 raised to the n plus 1, if you see that, or if you see negative 1 to the n, the purpose for putting that in there is it makes the signs alternate between positive and negative on your terms. Okay, and you'll see that when we try to substitute in a couple of the values. So like u sub n, let's do u sub 1. We would substitute in 1 for both of these little n's. So it would be negative 1 to the 1 plus 1 over 1. So this would be negative 1 squared over 1. And what's that going to be? 1. Okay, so based on what I told you, the next one should be negative. If I go positive, negative, positive, negative, positive, negative, whenever you see one of these. Okay, and the difference is just whether it starts positive or whether it starts negative. Okay, and so I'm going to put in 2 to get the second term. So negative 1 to the 2 plus 1 over 2. So that would be negative 1 to the third. What's negative 1 to the third? Negative 1. So you'd have negative 1/2. So basically, negative 1 to an even power is going to be positive 1, because every 2 negatives cancels out to make a positive. So negative 1 squared, or to the 4th, or to the 6th, those all come out to be 1. And anything to an odd power is going to come out to be negative 1, because every 2 makes a positive, but then you have 1 left over. Okay, and so we'll do one more. Negative 1 to the 3 plus 1 over 3. So what would I get? So you can see just with our first couple of terms, that's not really enough to establish a pattern, but 1, negative 1/2, 1/3. Can you guess without us plugging in the next one? Yeah, because it's just over n every time. So this is just making it alternate, and then it's just going up 1 every time. So what's next? Yeah. One more? Yeah. Okay. So you can kind of see that you can establish some patterns there. Okay. Yes.
So it's just random sequences and then active doing explicit.
So this is an explicit formula that's telling you how to do a sequence. It's not particularly arithmetic or geometric, but they just give you a formula. It's explicit because if I want the 100th term, I can substitute in 100 without solving it all at once before it. Do you have a question? Somebody? What? Oh, there you are. What? Yes, both of those are explicit. Yes. I'm old. See, so I thought she was talking. Okay, sorry. Okay, factorials. N factorial. If you've done factorials before, I don't know. Does anybody remember a factorial? Kind of. What do you remember about it? Okay. Do you know anything about the patterns? Okay. So let's say you have 5 factorial.
Isn't it like you add 1, 2, 3, 4, and 5?
Almost. You multiply 1, 2, 3, 4, and 5. Okay. So you start with whatever that number is, and you multiply by each whole number going down until you get to 1. So 5 factorial just means 5 times 4 times 3 times 2 times 1. It is. It means factorial. So it means so this is the actual definition. You start with n, and you multiply by going down by 1 every time until you get down to 1. It means factorial. So you read that 5 factorial. So what do we got there? 20 times 6, so 120. So 6 factorial would just mean 6 times 5 times 4 times 3 times 2 times 1. 0 factorial is defined to be 1. She doesn't like it, so that's okay. So you're not going to let me get away with why is 0 factorial equal to 1? I'll tell you. It does form what we call a consistent system. As far as if we want the rest of the mathematics, remember mathematics is a system of working with things that we know. So if you look, and I'm going to show you a couple of things that keep it straight. So n factorial just means you start with n, you go down by 1 every time, multiplying until you get to 1. Okay, now that means that n factorial would be the same as n times n minus 1 factorial. Now, we got to see if you buy that first. If you look at this, just that part, that would all be n minus 1 factorial, because what they're doing is they're starting with n minus 1, starting with whatever this is, and going down by 1 every time. So if you look at n factorial, that's the same as n times n minus 1 factorial. I have to know if you buy that first. A couple of yeses. Okay. Yes, no. For example, let's say that I had 5 factorial. I could say that that was 5 times what? Times 3 times 2 times 1. Okay. You can also say that it's, sorry I'm writing funny, but 5 times 4 factorial. Because what's this? 4 factorial. So that's the idea, is you can, on any sequence, factorial, you can actually just go 7 times 6 times 5, and then just whenever you're tired of it, it still would be the same thing if you just say, oh, go the rest of the way, times 4 factorial. Okay, and it kind of depends what your purpose is, whether you would stop or not. Sometimes when we're canceling, it can be helpful to stop at a certain spot. Okay, so that's why n factorial is the same as n times n minus 1 factorial. They're like, keep on going. Okay, so let's just say we put in 1, because that's one of the things we're interested in is 1 factorial. Well, what do you think 1 factorial is? 1, because you start at 1 and you keep going down until you get to 1. So that's kind of okay. But if we put it into this definition, you have 1 factorial, and then n is still 1 everywhere. Okay, so put in 1, put in 1, put in 1. So you have 1 factorial is 1 times 0 factorial. Okay, so you have, well, I already said that. We already simplified that. 1 factorial is 1 times 0 factorial. And you already agreed 1 factorial is 1. Okay, so if you have 1 equals 1 times 0 factorial, divide both sides by 1, what is 0 factorial? Okay.
So 0 factorial doesn't literally equal 0.
Right, it literally equals 1. You are correct. Okay, and then I have another one, but I don't know if you want to see it or not. Yes. You can also see the reason. Well, I have like other reasons. Do you want more reasons, or are you satisfied with that reason?
I'm satisfied. I am definitely satisfied.
Oh, Alfie's not. Okay, there's another reason. I got a couple of reasons. Okay, so if you look at this, do y'all remember doing combinations? Yes, it is the pyramid thing. You are exactly right. And I like that she said that. But here's the thing. I like talking to y'all about math. The only problem with that is I like to talk about so many different things that then I have trouble finishing what I started finishing with. Yeah, y'all remember Pascal's triangle? Okay, so Pascal's triangle starts with these 3 1s, and then you always keep a 1 on the outside. You add the 2 numbers above it to get the pattern. She's on to me. She's got it. Okay. Now those are actually the same as combinations. So this is the same as the combination of 0 things taken 0 at a time.
Okay, so hair.
Yeah, or a unibrow. Not seeing it? Okay. So if you think about that, if I have 0 things, how many ways can I choose 0 of them? Oh, 1 way. I can choose none of them. Okay? And then, so these actually correspond to, this is how many ways if you have 1 thing, you can choose none of them. If you have 1 thing, you can choose 1 of them. Okay? So this is actually a pattern of combinations. This is 2 taken 0 at a time, 2 taken 1, 2 taken 2, 3 taken 1, 3 taken 2. Oh, sorry, you got to start with 0. 3 taken 0, 3 taken 1, 3 taken 2, 3 taken 3. Okay, so this is a pattern of that, but this is a formula for combinations. And combinations is like if you're forming a committee, and so if you have 4 people and you want a committee of 3, how many ways can you do that? That's what a combination is. Okay, so you know, if you have Meredith and Alfie and me, and then you switch the order of us, you still have the same committee. Yeah, aren't you lucky?
Yeah.
Okay, and so when you do combinations, you don't count it again if it's the same people in a different order. So this is a formula for figuring it out. So for instance, if you want to say the combination of 3 things taken 0 at a time. Okay, so how many ways, if you have 3 people, can you choose 0 of them? Well, there's only 1 way to do that. Okay, and so if you substitute into the formula, this is your n, and this is your r. So I've put in for n and r. And you come out with the 3 factorials canceling. So you have 1 over 0 factorial, and the only way for that to be 1 is if 0 factorial is 1. If we had division by 0, our whole system fails. It explodes. Okay? And that kind of goes along with one more thing that's kind of weird, but I kind of think it goes along with it. Anything to the 0, we always tell you that's 1. Okay? And so if you think about it, if you had x to the 7th over x to the 7th, anything over itself is 1. And we also have the rule when you divide, you subtract your exponents. So x to the 7 minus 7 is x to the 0. So that has to be 1. So a lot of this is just building a consistent system that will work. Okay? So there you go. That's why it equals that. Okay, so if we take a look at this at factorials, there is a little bit of a difference between these. Okay? Well, what's the difference you can visually see between these two? Yeah, the parentheses are different. So either I have to do this first and then start going down by 1, or if you look at this one, this is like 2 times n factorial. So it's like that. Okay, you have to do the n factorial first. Okay, so let's do that. Just to kind of show you, this would be like having 2, and then n factorial is n times n minus 1 times n minus 2, and it keeps going. And you could distribute the 2 to all of that, or you could just do all of it first and then multiply by 2. Now this one is different. When it says 2n factorial, the first number they want you to start with is 2n. So the very first number is 2n. And then you go down by 1 every time. So if you go down 1 from 2n, you're at 2n minus 1. Down 1 again, where are you? Okay, and so on. And you keep going, by the way, until you get to 1 on both of these. Alright, well, this says that I want the first 4 terms, and I'm guessing that somebody else besides me can do the first 4 terms. I bet somebody could do the first, somebody could do the second, somebody could do the third, and somebody could do the fourth. All you gotta do is plug in 1, plug in 2. I leave the floor to you. I will restock candy while somebody picks it up.
You ran this one, right?
Did I?
Yes.
Yeah. I've been gone. Okay, so listen up. You got the microphone. You have to put the microphone on.
Oh. I don't know how to put this microphone on.
You clip it to your shirt.
Oh. Okay, so the first term is going to be 1, so the first term is going to be 1, so you plug in 1 for n, so
That's it.
yeah, it's just it, so it's just 1.
Perfect.
Yeah.
That makes it 2. Flip it on and tell them about it. Thank you. I'm not so sure about your chair.
Okay. So,
You can't see it.
I'm not sure about his chair, but it is true.
is that better?
Yeah.
Okay. So the second term, you would have 2 squared over 2 factorial. So 2 squared is 4, and 2 factorial would just be 2 times 1, so that would be 2. So it would be 4 over 2, which equals 2.
Gorgeous.
Annie! Oh, Annie! Way to go.
I'm gonna kill you. What is the term? Jude, if
Oh.
you need it.
Where does...
Okay.
I have weak
Annie, I'm gonna
fingers.
eat it.
I can't
It's
clip
okay.
it.
Just hold it close.
Eat it.
Okay, I hold it like this
I'm
then.
gonna-
It's kind of weird, but
Whoa.
sorry.
We can't see it.
How about now? Okay. So, I guess the next thing would be 3. So it would be U3 equals 3 to the squared. And then 3 factorial, and 3 factorial equals 3 times 2 times 1, which equals 6. So it would be 9 over 6, which would be 3 halves.
No matter how much you get. Oh wait, I want to.
I'm just gonna hold this so I don't really want to put this on. Okay, where's the... Alright, so... I'm gonna get over here, okay? So 4 squared over 4 factorial, that's 16 over 4 times 3 times 2 times 1. So that is 16 over 24, if I can do math correctly. And we can simplify that, it's 2 over 3, and there's the answer. Yay! Okay, and then this is some stuff with evaluating factorial expressions. And so you can do this really simply. By the way, you can also do factorial in your calculator, but I want you to know how to do it and be able to simplify it without the calculator. Partially because if you know how to do it with numbers, you can then do it with variables. So you can take something, if you had to multiply out 10 times 9, I'm going to write it out the long way the first time, times 7, times 6, times 5, times 4, times 3, times 2, times 1. And then 2 factorial is 2 times 1. And then 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What do you notice? All of these are just gonzo. Okay? But I wrote a lot of stuff out that I didn't really need to write out. Okay? So the shorter way to do that, because all of those are going to cancel, is you can actually just start with the higher factorial and go down by 1 until it matches the factorial on the bottom, or where, you know, whatever spot you're not already. So like this, I could have just said 10 times 9 times 8 factorial. And then 2 factorial I might as well say is 2 times 1. And 8 factorial is 8 factorial. And then you're not bothering to write out all that stuff. Okay? Because 10 factorial is 10 times 9 times 8 factorial. Because 8 factorial just means you keep going. Okay, so that can save you some trouble. We can also go ahead and reduce now. I mean, you have 90 over 2, so you can just say that's 45. Or if you feel like canceling the 10 and the 2, you can. Preferences, or does it, kind of a spoiler alert, I already kind of said what the answer was, so, okay. Alright, so similarly, it's a little bit hard to think about with variables, but you just start with that whichever one's higher. So between n and n factorial, between n factorial and n plus 1 factorial, which is bigger? N plus 1 factorial. So I'm going to start with that one. And I'm going to go down by 1 every time until I match what's in the numerator. So if you go down 1 from n plus 1, where are you? So I'm just going to say factorial, because that already matches. So I could keep going, like after n would be n minus 1, and then n minus 2. You just keep going down by 1. But I already matched something that I can cancel with. So this would actually just be 1 over n plus 1. Okay, which one is larger between these two? The denominator one, yeah, because this is 2n minus 1 and this one's 2n plus 1. Okay, so I'm going to start with 2n plus 1. I'm going to keep going down by 1 until I get to what's in the numerator. So what is down 1 from 2n plus 1? What's down 1 again? And that's far enough, because it matches what I have in the numerator. So you would just have 1 over 2n plus 1 times 2n, and up to you whether you multiply that out or not. But you've certainly simplified it. Now the next kind is the, and that was just simplifying with factorials. It wasn't a sequence or a series or anything. This, however, is going to be back to finding a sequence, but this is the other kind of formula, recursive. So the other kind that we already did was explicit. Put in the number. If you want the first term, you substitute in a 1. Want the 100th term, you substitute in 100. This is recursive because it depends on the terms before it. Okay? And what they're telling me here is that these, the first two, are both going to be 1. Okay, so I kind of changed notation. This is a sub 1 and a sub 2. It's also the same as if you did u sub 1 and u sub 2. Okay, so it's any variable can really be used for that, but they're telling you the first two terms in the sequence. Okay, and so you have the first two, if I was listing them out, would be 1 and then 1. Okay, now this says this works for n greater than or equal to 1. Okay, so I could put in a 1 right here. That's the first number this formula is good for. So this would be a sub what if I put in a 1? A sub 3 would be equal to a sub what? 2 this time, plus a sub 1. And that's for n equals 1. So what they're saying is to get the third term, you need to add the second term and the first term. So add these two, what do you get? Okay, so we got that one. Okay, now if I let n be 2, then I would have a sub what? Equals a sub plus a sub. Okay, so I'm supposed to add this, to get the fourth, I'm supposed to add the second and the third. So what do I get? Now, you can actually read this, if you understand the formula, you can keep substituting in 1, 2, 3, but what it's saying is to get the next term, n plus 1 is the term right before this one. and n is the term right before that one. So to get the next term, you add the term before it and the term before that. So the previous two terms. So that same pattern is going to keep holding. Correct. Okay, so based on that, what do you think the next term is? And the next? And the next? Okay, that's enough for me. I get bad at adding. Okay, have you ever heard of this sequence before? Have you heard it called anything? The Fibonacci sequence. So this is called the Fibonacci sequence. So that's a recursive formula. Fibonacci. Well, that's even better. Okay, so this one says find the first 5 terms of the sequence defined recursively. So this one is a little different. It's not a famous one, so spoiler alert. Tells me the first one. So the first term is 3. Now can you read that without us substituting in for k, can you tell what this formula is trying to tell you to do? Yeah. Just take the term before it and divide by 2 or multiply by half. Okay, see, to get the next term, this would be the term right before it, multiply it by half. Okay, now if you don't like that, you can put in 1. So if you put in k is 1, that would say u sub 2 is half of u sub 1. And you could keep substituting in, but it's going to keep doing that pattern. Just take half of the term before. So, first term's 3, what would be next? Oh, I want to do fractions. Oh, you're correct, of course. But then it gets easier to write the fractions if I have to keep multiplying by a half. So what's next? And then next? And one more. Yep. That's easier than the decimals for that one if you're not sitting there with a calculator. Okay, the other thing I need to show you is summation notation. You should have seen summation notation before. Sounds like Dalmatian plantation, kind of, sort of. Okay. Yes. They're going to define a sequence, so that's for this sequence. Does that make sense? And they give you a different formula to describe a different sequence. All right, so on this guy right here, the I is called the index, the 1 is the lower limit, the n is the upper limit. Okay, and what they're telling you to do is something like this: is put in 1, and then 2, and then 3, and then 4, all the way till you get to whatever the upper limit is. So, for example, on this one it says, find the summation from 1 to 4 of 3i plus 1. So what they want you to do is substitute in 1. So 3 times 1 plus 1. And then they want you to substitute in 2. And then they want you to substitute in 3. And then they want you to substitute in 4. How did I know when to stop? Upper limit's 4. Okay, so you start it, and it could start at 5 and go to 17. Okay, but typically we start with 1. So this would have been 4, 7, 10, 13, so 20, 30, 4. Your calculator can also do this, and since I'm double lessoning you, we're going to do the next one with a calculator. So that one says, it's kind of blurry, isn't it? The summation from 1 to 5 of negative 1 to the I minus 1 times I factorial. So I want you to make sure you have a calculator. So if you don't have one, take a second to go get one, and we're going to put that on the calculator. You, by the way, might find this useful in your test as well. My calculator is slow waking up. By the way, I'm pretty sure we have an odd schedule on Monday.
We do.
Yes. We're back with you.
What?
Oh, no, this is an even.
Okay, I was just making sure I wasn't missing something because I often do. So,
I always confuse them as an even only, so that
Yes.
as an even and
gotcha. All right, calculator, wake up.
Tuesday schedule on Monday, Wednesday schedule on Tuesday, Thursday schedule on Wednesday.
So it's all wrong. Got it.
Thursday.
It's everything you think it is.
Okay. Go to a calculator page, and then I want you to hit the little key to the right of the 9, which is like a little template. And you have lots of choices here. This is the one you want. By the way, this one right here is the same thing, only it's a product. So instead of adding every time, you multiply every time, which I think is kind of cool, but we don't do it in this course. Neither have I done it in any course I've ever taken. I don't know, but it's kind of cool that it's the same thing, only multiply. Okay, so click this little guy, and it's nice because you do exactly what it looks like on the paper, which you may not be able to see now, but we had what's that? Okay, so you just put in I equals 1, 2, and that one was 5. And then we want in parentheses -1. By the way, if you do a minus when it's a negative, it won't like you. Raised to the I minus 1. This actually is a minus. And then I'm going to arrow over so I'm not in the exponent any longer, and that's going to be times I factorial. Now, the factorial is down here to the right of the G. To the right of the G, there's this little button, and they don't mean they're excited about it. That's actually a factorial. Okay, and then you hit enter, and that is the answer. Question? Yes? Yes, but it is unlikely that that's what I'm going to want. But it is nice to check. So when you have summations, you're going to need, I'm going to teach you how to do summations. If it's an arithmetic or geometric, and that's what you're going to have to do. But it could come in handy. At least to check, if nothing else. Yeah. It was to the, let me look again, right here to the right of the G. So you hit this guy. Okay. That I think is more, it's not like a mathematical symbol, but you can write programs and stuff. And you might, in the program, you can say, ask a question. It can just literally be a question mark. Yeah, you can ask, you can make it where it's giving you little quizzes. What's that? Well, I'm going to actually skip the next page and go to here. Okay, so we're going to skip over, that was your, you know, I said a double. Well, I gave you like 3/4 of that one, and we're going to go on to arithmetic. Okay, so arithmetic sequences. And it's okay because you did them in Algebra 2, so you can handle it. Okay, the definition is a sequence that is generated by adding the same amount every time, and the amount that is added is called the common difference. So common difference. And we use D for common difference. Formula, yes. But they tend to more typically test you on arithmetic and geometric. But there are all different kinds of sequences. No, geometric will be next class. Now we talked, the first one that I showed you was a geometric sequence. We just didn't do anything with it besides look at it. And go, oh, we multiplied by 1/2 every time. And then, it is a D. And the formulas for arithmetic and geometric are on your formula sheet. I'm just going to go ahead and point that out right now. They're under Topic 1, Algebra. So all of these we will do in the next 2 days. Okay, so these two are what I'm doing today. This is how to find the nth term of an arithmetic sequence. That's an explicit formula.
This is how to find the sum of the first n terms in the arithmetic sequence. And then these three formulas have to do with geometric, and we'll do those next time. But the formulas are there for you. Okay. The first term of the sequence is known as u sub 1. Okay, now some books will use a sub 1. They can use any letter they want, but your formula sheet kind of goes with the u's. Okay, so u's plural. U, the letter U, plural, u's.
Oh. Okay.
Or if you're, I don't know, some places they might use u's to talk about u's. U's all good kids. But I wasn't using it like that. Okay, this says determine if the sequence is arithmetic. If so, identify the common difference in the first term. Okay, so if you look at this one, if I'm asking you if it's arithmetic, I'm asking you, are you adding the same thing every time?
Yes.
Yes, 5. He's got it. So, yes, 5. That's the answer. Okay, so the common difference is 5. And u sub 1 would be what? Yep. Okay, what about the next one? Okay, so it looks like you're subtracting 4 every time. That just means your common difference is minus 4, negative 4. Okay, because you did minus 3 minus 4 gives you negative 1, negative 1 minus 4 gives you negative 5, and so on. And u sub 1? Did Jude give up on me? The restroom, I would assume. Okay, what about the next one? No, I gotta know. What? Does it have a pattern to it, though? Yes. Well, so you got multiplying by 3, and just so you know, I'm going to get ready for you. This is a geometric with R is 3. That's next class, but it's just the same thing, and u sub 1 is still the same. But if you multiply by the same thing every time, that's geometric. We have formulas for that too. And R is 3 because you're multiplying by 3 every time. Okay. Now, we can actually take the recursive definition of an arithmetic sequence and come up with an explicit one. Okay. So, basically, if you think about it, the first term is just the first term. If you have the first term, what do you do to it to get the second term? You add d. Okay, so the third term, what would you do? Yeah, you'd add another d, which would just be 2d. And then the next one? Okay, so in general, what you're doing is you're taking the first term. You're back. You didn't give up on me.
I left this school for a bit of impact.
Thank you. I'm so glad. Okay, so I'm trying to figure out how many d's do I have to add to find the nth term.
N-1.
You got it. And the reason is because you don't have to add d for the first term. So you're adding it for all the other terms, but not for the first term. So n minus 1 d's. Okay, and that's your formula for finding whatever term that you want. So u sub 1 just means the first term. D is the common difference. And n is the number of the term. So in other words, if you want the 20th term, n would be 20. And so this would become u sub 20. And u sub 20 would mean the 20th term. Okay. So this says on the above examples, use the nth term rule. Determine the nth term rule and find the 75th term of the sequence. Okay, because we have an explicit formula, it's really easy to find the 75th term. And we're just going to do it for one of them. So we can't do it for 3 because it's not arithmetic. You want to do it for number 1 or number 2. Okay, so number 1, we know that u sub 1 is 0 and d is 5. So to find the formula, you just substitute into here. U sub 1 is 0. And then plus n minus 1 times 5. And that's your formula. You can leave it like that. You can call it 5n minus 5. Whatever you want.
And then just to find the 75th term, what would you do? Okay, and y'all have calculators, so I'm hoping you'll tell me what that is. Because I actually don't know. What is 74 times 5? You going to make me do it? No. 370? Thank you. Okay, the next one says, write the first 5 terms of the sequence, determine whether or not the sequence is arithmetic. Okay, so here's B sub n. So I just have to substitute in 1, and then 2, and then 3, and then 4, and then 5. So the first one would be 3 times 1 plus 5. So 8. If only I had 4 more people to find the next ones. Jude, you're after.
What?
You're next.
I just got back.
It's the same thing we were doing when you left the first time. She's going to substitute in 2. You're going to substitute in 3. I was trying to get your turn. Okay. You want your turn now? Okay.
Yes.
Alright, who's got the 4th? Let's go, let's go. I need the 4th and the 5th. Beautiful. There we go. All right. Daniel for the win.
Yeah.
Oh, come on. Y'all know that you're going to work the most right now, and then you'll have a
How does this?
today.
How does this pit? Okay, I'm using this one.
All right. Okay, so they found the terms for me. The question is this arithmetic? All right, so I got a yes. If it's arithmetic, what's D? And you said 1? 8. Okay. All right. This one gives me a sequence, 2, 6, 10, 14, and it wants me to find U sub 49. Okay, now here's the thing. On the actual IB test, you can list out all the terms until you get to the 49th one. Okay? Now, I don't recommend you do that. That's the whole point of formulas. Yeah. Yes. Which is why all your tests are timed, and y'all look at me like I'm a horrible human being every time. Take your tests away. But you're practicing like what you're going to actually have to do, except I give you a little padded time. So it'll say like 60 minutes or 75 minutes, and I'm giving you 90 minutes. So, you know, because you're practicing. You're not already there. You need a little bit of leeway while you're getting ready. Okay, but yeah, they are definitely time tests. Usually people feel like they have enough time, though, to do everything that they know how to do on it. So, which is hopefully a lot. So this particular one, first off, I need to figure out, is it arithmetic? Yeah, which means I can use my arithmetic formulas. So tell me U sub 1. Tell me D. So I'm going to write a formula, okay? And it's U sub n equals U sub 1 plus n minus 1d. And remember, it's right here, the nth term of an arithmetic sequence, and there's the formula. Okay, so you don't even have to remember it, even though it's kind of logical. Okay, so for U, you want U sub 49. Now here's the thing, sometimes people get confused between n and U sub n. Okay, U sub n means the 49th term. Okay, U sub whatever it is. So that's the nth term. This is just the number of the term. So that's a 49. Okay, so 49 is the number of the term. Whatever the term actually is the U sub n. Okay, so it would be U sub 1 plus n, which is 49, minus 1 times the common difference. Why didn't I substitute in u sub 1? I don't know. Sorry. Is that what y'all were going to ask? Sorry. That's a sad looking 2 now. Okay. So we knew everything. We could substitute it in. It's just the first term. And you want to add 4 48 times. So 2 plus, what is 48 times 4? Thank you. Okay, so you can see where it's a lot faster if you just use the formula. But I just want to kind of remind you that if you can show logic on the test, that they will still take it. And obviously, that would be wasting a lot of time writing out that many terms, but it is permitted. Okay. Okay, you've made it to the last page. And next time shorter, because all we have to do is geometric. There you go. All right, so now they're going to add a little pizzazz to it, okay? So it says, determine the rule for the nth term given the 2 terms in the sequence. So they gave me the 8th term, u sub 8 is 75. They gave me the 20th term, u sub 20 is 39. Okay, so what's ugly about this is they did not give me the first term, they did not give me the d. Okay, but what I'm going to do is I'm going to write that down, the only formula that I have on my formula sheet. Okay, because it does kind of give me the structure of what I need. So what you want to do is say, what am I going to have to do to go from the 8th term to the 20th term? Okay, so if you were, put the higher one over here. So the question is, if I started at the 8th term, how many d's would I have to add to get to the 20th term? 12. Okay, now notice the pattern is kind of the same. See how what's in here is this minus this, the n minus the 1, and here it's the 20 minus the 8. Okay, because basically you start at the 8th and you didn't start at the first one. You're going to have to add d every time until you get up to the 20th one. Okay, so it's just instead of having to write it out. Okay, so if we know that, what we can do is substitute in u sub 20 is 39. U sub 8 is 75. Do you think d is going to be positive or negative? Negative, yeah, because it's going down. Plus 12d. I subtracted the 20 and the 8. So to get from the 8th up to the 12th, that's how many times I would have to add d. Okay, so we're going to solve this equation. So subtract 75. And you want to tell me what that is? Okay, so negative 36, divide by 12. So we know what d is. So that feels pretty good. But it says determine they want me to find the u sub n rule. But I need 2 things to find the u sub n rule. What's the other thing I need? I need u sub 1. Okay, so basically now I can just go between any 2, but how about between the 8th and the first term? So you could write it would be like u sub 8 would be u sub 1 plus how many times would you have to add d? 7 times. Just subtract the 2. Yes, I just had to go up there because I didn't have enough room. Okay, so the 8th term is 75. I want to know the first term, and then 7 times negative 3. So you have 75 equals u sub 1 minus 21. Add 21. And you have 96. So if you know your d, and you know your u sub 1, you can combine it and get a formula to find any term you want. So you just write the general formula, u sub n equals u sub 1 plus n minus 1d. And you would just substitute in the u sub 1 and the d. So 96 plus n minus 1 times negative 3. And that's what they actually wanted. Was, hey, you know these 2 random terms, you know it's arithmetic, find a general formula.
What do you think about that? I think I'm wearing you out, but it's okay. You're going to make it. Power up. You're going to make it. Okay, here's what I need you to do. Everybody get up, go get a piece of candy, and go sit back down so that you will have something left to give me for the last part of this, because it's really important. If I run out, I will restock. Okay, that problem we just did was actually the hardest kind there is. That's not even that hard. Okay? This one is actually easier, except that I did something crazy. That should say U sub 5 right there. Okay, so you have U sub 10 is negative 23, U sub 31 is negative 128, and they want to know U sub 5. That's supposed to say U sub 5. Okay, well that's actually easier a little bit because I don't have to go and find the first term, I just need to find the fifth term. Okay, but I'm going to start kind of the same way. I'm going to say U sub 31, I'm kind of putting the later term over here, equals U sub 10, and then you have to figure out how many D's would I have to add. 21 D's to go between the 10th term and the 31st term. Okay, so then just substitute in the numbers you know. Negative 128 would be the 31st term. Negative 23 would be the 10th term. And we're going to figure out what D is. What do I need to do? I like it. So what do we have there? Negative 105, thank you, equals 21D. And then we're going to divide by 21. I hope that's something lovely. That is lovely. It always makes you feel good to get nice answers, although life does not always have nice whole number answers. I appreciate it when it does. Okay, so they want the fifth term. So basically, you could go between any two terms that you want, but I usually pick the one that's closer to the one I'm getting to because I figure it'll probably keep my numbers smaller. So I'm going to go between the 10th term and the 5th term. Now, if you want, you can do it just like the last one where you figure out U sub 1, figure out a formula, and then find the 5th term. But I'm just going to go between the 10th and the 5th. How many D's would there be between the 10th and the 5th? Yeah. Okay, so the 10th term is negative 23. I want to know the 5th term, but I know I'm subtracting 5 every time. Okay. So that would just be negative 25, so I'd be adding 25 to both sides. And what would U sub 5 be? We did it! Okay, so all of that was talking about finding the nth term of a sequence. Okay, you know something about the sequence and you want to find some random term. So now we're going to switch from being a sequence to being a series. What did I say the difference between a sequence and a series was? I don't know. Sequence is just a list. Series is added. Yeah, question? Okay. Yes. So now I know at least like what it's going down by every time. It's going down by 5 every time. So then I was like, okay, if I know D, if I know one of the terms, I can basically add or subtract the D the right number of times to get to any other term I want. So I wanted the 5th term, so I could go between the 5th and the 31st or the 5th and the 10th. That was the question. And so I went between the 5th and the 10th just because they were closer. And I said if I had the 5th, I would have to add D 5 times to get to the 10th. Yes?
How do you say his last name?
Gauss. Okay.
We had a debate in my house the other day about how you
Gotcha. Okay, so I have a little story to go with my what we're going to do now. So the story is that a young mathematician named Gauss was given an assignment, or like his class was given an assignment by his teacher. And the assignment was to add up the first 100 numbers. So 1 plus 2 plus 3 plus 4 all the way up to 100. Seems to me like that's pretty good. Like, okay, I think I'll sit down for a minute. You guys just sit there and add from 1 to 100. But he did it very, very quickly. And again, this is one of those legend has it, so you can find the story, but I guess I don't guarantee its authenticity, but it is a legend about Gauss. And Gauss, it's not debatable, is a very good mathematician. But it is said that this was like in 3rd grade, and he added it up in like 30 seconds. Okay, any thoughts? Has anybody heard the story before or kind of know?
He did that. It was like 20 minutes, but...
Okay, do you remember what his shortcut was? No. Okay, I'm going to write out some of the numbers going this way. Kind of try to meet in the middle. Okay. What do you notice when you add these two? What do you get? What about these two? What about these two? Okay, so how many pairs of 101 do you have? So that's it. Because there's 100 numbers, and we're pairing off every 2 of them. Okay, so pretty quick fellow, okay? And that is the sum. Okay, now this can be generalized into this formula. Okay, and this is for arithmetic only. It doesn't work for everything in the world, but it does work for arithmetic. If you take the first term and the last term and add them, okay, so 101, we added that, the first term and the last term. We got 101. And then we multiplied that times half the number of terms we had, because we were pairing them off. Okay, now this formula is on your formula sheet. Now there are 2 of them. Okay, so they did one of those where they show you 2. It's the second one. It's this one. I'm also going to show you how they got that one. Okay, but just take the total number of terms, divide it by 2, multiply it by the first term plus the last term, if you have that information. Okay, now, this, if you notice, is just what we did. It was the sum of the first 100 terms. Okay, and so we just did 100 divided by 2, the first term plus the last term. Okay, and that's what we did. N is the number of terms, or the number of the term. U sub 1 is still the first term. U sub n is still the nth term. Now there is another formula on your formula sheet, and the reason for that is you don't always know the last term. Okay, it was easy for us because we were going up by 1 every time and there was 100 numbers. But let's say we were going up by 45 every time. You would have to figure out what the last term was. Okay, but what you can do is you can substitute in. So if you don't know the last term, you can substitute in the formula we had for u sub n. And the formula we had for u sub n was u sub 1 plus n minus 1d. So instead of u sub n, you can put in u sub 1 plus n minus 1d. That's just first term. It's a subscript, u sub 1. It's like down below. Okay, so do you see what I did? Instead of u sub n, I'm putting the formula for u sub n. Yes, no, maybe? Okay, so you can combine that. U sub 1 plus u sub 1 is what? You got it. 2u sub 1 plus n minus 1d. So this is another formula on your formula sheet. They use this one and the one that's already in the box over here, and they both work. It's just one of them, they tried to save you the trouble of substituting the other formula in. So you'd use this one if you knew the first and last term, because it's fast and furious. This one you'd use if you didn't know the last term, okay, but you knew d, and you knew how many terms you wanted. Okay, all right. So if you take a look at this one,
It says B sub n is 3n plus 5. Determine S sub 20. Okay. So what that means is they want you to put in 1, 2, 3, 4, all the way up to 20 and add it up. A couple ways to do that. One is you could write it as S sub 20 is the summation from 1 to 20 of 3i plus 5. You put it on your calculator, it'll tell you the answer.
Is that a divide sign or a plus?
This is a plus.
And the one above it. Oh, 3n is plus 5.
Yes. Okay. If we were trying to figure this out, though, the sum using one of these formulas, let's think about what do we know. Do we know n? What is it? 20, because we want to know 20 terms. Okay. Do we know the first term? Or can we figure it out? Okay. So the first term is what? Yep. Yep. Are you all okay with what she did? She just put in 1. 3 times 1 plus 5 gives you the first term. Okay, do we know the last term? Or can we find it? So u sub 20 would be 3 times 20 plus 5. So 65. So I think I'd rather use that formula. What about you? Okay, so S sub 20 would be n over 2, so 20 over 2, the first term, which is 8, plus the last term, which in this term is u sub 20, plus 65. So 10 times 73, so 730. I've almost made it. You only have 2 more problems. You can do it. Okay, so take a look at this sequence. It says, given the sequence 3, 9 halves. By the way, I would never allow that on an IA, so I should fix it on this. It has to be written looking like a fraction. 3, 9 halves, 6, 15 halves, and so on. Determine this S sub 40, which means the sum of the first 40 terms. Tell me something that you know.
First term?
I like it. So u sub 1 is 3. Do I know D? It looks a little gross, right? It'd be like 3, 9 halves would be 4.5, and then 6, and then 15 halves would be 7.5. You got it. And basically, you take any term minus the previous term, like if you're not sure. But we are assuming that it is arithmetic. Okay, so we know u sub 1, we know D. When it says S sub 40, that means n is 40. That's how many terms they want us to deal with. And we want a sum. So the question is, do we want this formula or this formula? Which one? Yeah, second one. Okay, because we don't know the 40th term. Now, if you want to take a second and find the 40th term, that's fine. Okay, that's all this formula does is put finding the 40th term into the formula. Okay, so if you don't know the last term, then you'll use this one. If you do know the last term, you'll use this one. Okay, so we're going to do S sub 40, and it's n over 2, so I'm following this. Okay, are they being crazy in the hall again? I don't know what that is. 2 times u sub 1 plus, what would n minus 1 be, just to kind of make it look nicer? 39, and D is 1.5. Okay. So that's 20 times 6 plus, I don't know, is somebody going to help me out with 39 times 1.5? Okay. And the rest of it. So this plus this, so then times 20.
and you have made it to the last problem in your double lesson. Here we go. Now, I don't recommend this, but suppose you put $100 under your mattress at the end of each month. Okay. Not recommending it.
I just like to imagine spending
The mattress.
Oh dear.
a few months to imagine.
There you go.
Keep this pen on me.
All right, so you put $100 under your mattress at the end of the month. You continue to put money under your mattress each month and increase the amount by $5 each time. So first month you're putting in $100. Then what are you doing? And then what? Okay, and they want me to add up and figure out how much money is under my mattress after 1 year. So what is N? Well, we're just doing it per month. Okay, and then what's D? And what's U sub 1? Okay, which formula do you want to use? Well, I don't know the last term. So second one. Okay, try it. See if you can get the answer. Come on, I told you everything. Just plug it in. See what you can tell me for a number. So this would be S sub 12. So it would be 12 over 2. 2 times 100 plus N minus 1, so that just be 11 Ds. So 6 times 200 plus 55. And hopefully that comes out to 1,530. And if you're not here, you're getting a worksheet, so you'll have to stop by and